It's a bright sunny day on the southwest coast of Ireland. These local marine researchers have taken their boat out to check on their seaweed farm. The algae they planted just a few months ago has already grown into an impressive underwater plantation.
You can see quite clearly there's quite a large crop of seaweed down here. The plants are somewhere between 2 and 3 meters long. So at this stage, we're very close to harvesting.
Seaweed farming is a growing business in Ireland. Demand for seaweed is increasing in sectors like healthcare and food. This is an innovative European research project to study algae as a potential biofuel crop.
Seaweed doesn't require any fertiliser. There's no space requirements either, like you would have with terrestrial crops. There's a lot of competition in terrestrial crops for food. And it grows very fast. The growth cycle, it's fully grown in 6 months.
Some species of algae contain sugars that can be used to produce bioethanol. Others are rich in oil that can be converted into biodiesel. Researchers are trying to make such fuels commercially viable by improving the algae growth and oil content. Along with seaweed, they're also studying microalgae, a species that grows and accumulates oil quickly when cultivated in bioreactors.
It would produce between 7 and 31 times more oil than the best terrestrial crop. That's what all the studies have shown. Okay, there's a lot more to do, but 10 years ago, people would have laughed at you if you put seaweed-based oil into your car.
The biggest challenge is extracting the oil trapped in the seaweed and microalgae cells. In this laboratory, researchers treat the algae powder with large amounts of solvents to increase the release of oil, but this method isn't efficient on a large scale.
Growing the algae obviously is the easy part. Whether it's macroalgae or microalgae that you're culturing, it's quite simple to grow. The hard part is extracting the oil from the actual algae. We need to look at the cheapest way to do it, using the least amount of resources.
A cheaper oil made of seaweed could revolutionize the emerging biofuel industry. This Irish plant produces 30,000 tons of biofuel each year by recycling used cooking oil, animal fats and other kinds of fats. The biofuel is blended with mineral diesel, making it more environmentally friendly. Researchers test algae oil samples with industrial-grade tools. For biofuel manufacturers, developing a new product at a competitive price would help them expand production.
Of course, our industry is always interested in this new oil because we can convert any type of oil in this process to make biodiesel. And the greener it is, the better it is for ourselves.
Algae grows almost anywhere as long as it gets enough sunlight, water and carbon dioxide. It improves air quality by absorbing the CO2 and reduces the negative effects of fish farming by filtering out excess nutrients.
The only environmental impact that you can say about the sea farm would be that it's beneficial. It's all positive. There is nothing negative about seaweed farm. I'm not saying that they will clean up the sea completely, but they do help to clean up the excess nutrients in the sea. So I like to see the seaweed as a sort of a mop, a nutrient mop. Julie, you have a bag?
And harvesting seaweed to develop an alternative to fossil fuels is just one of its merits.
I'm chewing it. It's quite tasty. Would you like to try some?
It's time for a bit of cooking at this research center in southern Italy. The recipe is a simple one. A few handfuls of natural textiles, a liberal dose of bio-based resins, and a pinch of bioadditives and enzymes. Stir well and place the mixture in an oven for a few hours at 60 degrees Celsius. Voila!
It's made out of linen fabrics and natural resins. It's a sustainable, completely organically derived product.
It It is in fact a new composite structure made solely of renewables. The researchers hope their new biomaterial will soon replace plastic composites made from limited fossil resources.
Noi siamo convinti della possibilità concreta.
We're convinced that very soon we'll be able to replace fossil-derived materials with exclusively natural materials.
Esclusivamente a materiali di derivazione naturale, derivati da fibre di cotone.
We're talking about materials born out of byproducts like cotton, linen or hemp, or resins made with sugarcane or other crops which are not aimed at the food market.
Da altri tipi di legna non destinati ad uso commestibile.
The first step towards bringing a new biomaterial to market is to test its mechanical characteristics. The researchers want to see how they measure up to petroleum-based composites. They also want to know how resistant their material is to fracture. And they check its elasticity and plasticity.
In mechanical stress tests, it doesn't perform as well as conventional petroleum-based plastics. It can be deformed more easily, for example, and it isn't quite as stable as a fossil-based composite is. But that doesn't automatically mean that the biocomposite will have fewer applications than its petroleum-based counterpart. It all depends on what kind of final product you want to make with it.
And researchers have plenty of ideas on the drawing board. A number of possible concepts are currently under development. The new biocomposite could be used for automotive components or in the manufacture of musical instruments. But will developers be able to offer it at a competitive price?
Research is ongoing to increase the quality of the natural composite. In a year's time, we'll have a top-quality product. And it shouldn't be that expensive. The natural composite will cost between 20 and 25% more than current plastic composites. That would mean a price increase of just 30 or 40 cents per kilo for natural composites.
If all goes according to plan, say the researchers, the new bio-based material could hit the market within the next 5 years.
Dams that protect urban areas from flooding sometimes fail, resulting in catastrophic damage. What can be done to prevent such disasters?
Onder mijn voeten zijn 48 sensoren.
There are 48 sensors under my feet, constantly telling us how this dam is feeling and how it's behaving. This technology makes it the smartest dam in the world.
Eigenlijk is het een van de meest slimme dijken van de wereld.
The underground sensors developed within a European Union research project transmit measurements to data centres in several countries. Boston, on the east coast of England, is one of the main test sites for the new technology. The river rises dramatically with the sea tides, putting local citizens at risk.
Boston has some good sea defences, but they're not high enough. So when the surge comes through, it means that the walls get overtopped and potentially could fail. So it is at significant risk.
Engineers involved in the study have designed several types of sensors, reliable and affordable enough to be put in damp soil embankments.
Wat jullie hier zien, dat is een sensor.
What you see here is a sensor, a measuring device that has electronic components inside a stainless steel container. It has a tiny opening through which water can enter.
En het water is om de druk.
This device measures the amount of water in the dam and many other parameters, such as the underground temperature and the movement of the sensors inside the dam.
De hoek waarin hij verdraaid is.
These indications can be followed in real time using any internet-enabled device. A touchscreen panel installed in a Boston cafe allows the public to see how the system works.
Well, the sensor data information can be analysed, and you can gauge the stability of the embankment of the dam. And by knowing if there's any signs of change within the embankment, that's often a sign of failure occurring or potential failure occurring within the dam.
If the artificial intelligence anticipates a breach, it sends a warning to the responsible services that may otherwise be unaware of the weakening within the flood defences.
Currently, we use a visual walkover, so it means probably 2 or 3 times a year we get people viewing the asset, and it's from a visual point of view. This technology allows us to actually understand how the bank is performing, so it looks at probably how it's moving under pressure, whether we got leakages through the defence, and also we can see at an instant, because it's real time, what's happening.
The software calculates how fast the site will be flooded if the dam fails, and even suggests the best ways to move citizens into safer areas.
This system will allow you to show you the outline of the flood mapping. We can then run a life safety model, which will show the evacuation process that people can take. This can be used by emergency planners for them to be able to test various scenarios of evacuation to find the best evacuation procedure in the event of a failure.
If proved reliable, this system could be deployed in many urban areas in Europe and across the world to protect vulnerable cities from the imminent effects of climate change.